Hi everybody, in this video I talk a little bit about the different types of organ pipes, and there are flue pipes and reed pipes. So I'm going to use some wind instruments here as examples for those types of pipes. So in every musical instrument, the sound is caused by something that vibrates, and then there's usually some kind of resonator or some kind of space that amplifies that sound. So in both a flute and a recorder, what is actually vibrating is just the column of air that is inside the pipe. So in a flute, when I play a sound on the flute, there is no material that is vibrating other than the air that is contained inside this pipe. This is the same as most of the pipes on the organ, which are flue pipes. And all that is vibrating inside of a flue pipe is the air, the column of air inside the pipe. Now, a reed pipe, of which there are fewer, uses a reed. Now, on a reed wind instrument, you would have a reed like this, which is a very narrow, thin piece of wood. You soak it in your mouth for a few minutes, and the piece of wood is actually what is resonating, not the column of air, although that does resonate in the end. So when I put this on the saxophone, the main body of the saxophone and the fingerings on the saxophone act to amplify certain frequencies, but it is the reed that is doing the vibrating. The reed here, the narrow piece of wood, there is a slight gap between that and the mouthpiece, and that little gap is what is vibrating. So that's what makes the sound. We're going to see in a minute here that on the organ, it is flue pipes like the flute, where a column of air is vibrating, and reed pipes with a piece of metal instead of a piece of wood that causes the sound to initially start vibrating. So there are a few different categories of sound on the organ, and they're made by different types of pipes. So one thing that an organ tries to sound like a lot of the time is like a flute. And it does that through a flue pipe, which looks and operates a lot like a recorder or a flute. Another type is a reed pipe. It's supposed to evoke the sound of some more kind of reedy or brassy instrument. So in this case, we have an oboe. There's also bassoons and trumpets and trombones. So not exactly like an oboe, but trying to approximate the sound of it through using pipes. These pipes actually have a reed, well, a brass reed, that operates much in the way that a reed in a real reed instrument would operate. It actually physically moves. We also have pipes that are supposed to sound like kind of string-y or soft, like a string instrument. And these are also just regular kind of flue pipes. But then we have stops that are not supposed to sound like any other instrument, not flutes, not reeds, not strings, and these are the diapasons, or basically your meat and potatoes organ sound. And so that's the sound that people think of a lot of the time when they think of an organ. But you can mix and match these sounds together, much like in an orchestra. In a minute, I'm going to go up here and show you how this whole space is divided actually into two different rooms of pipes. And one of those rooms of pipes just plays out straight into the sanctuary, but the other room of pipes has a set of shutters, and those shutters kind of cut off the sound so that it's a little muted. You operate that set of shutters using this foot pedal, and if I do it quite quickly here, which I shouldn't do too fast, you can actually hear the shutters physically moving. All the sounds that are contained in that room are the swell, and it's called the swell because you can actually do a swell with it. That's it with the swell box closed, and that's open. So here we are up inside the organ, and my mom is out at the organ console using that foot switch to open and close these shutters. So when the shutters are closed, you'll hear much less from all of these pipes. So we're back up inside the organ. This is the ladder where we climbed up here. Here are our shutters for the swell half. The volume of these pipes can be controlled with that foot pedal by opening and closing these shutters. But in this room over here, we have the grape pipes, and they're separate with this door here. So the swell pipes are going to be totally contained in this box. So so that you can more easily control the volume of the sound. The great pipes here just go straight out through this kind of speaker mesh into the main sanctuary. So looking at these pipes, you'll notice that there's different shapes, and there's these kind of foils on top of, or sometimes scrolling down from the pipes. And those are adjusted to finely adjust the pitch. Moving these foils up or down allows for fine tuning. Now, you'll notice that pipes are bigger, pipes are smaller, but the name of each stop goes at the beginning of the set of pipes. So this is the melody 8-foot, so everything in these two lines of pipes would be for that particular setting. Now you'll notice as they're getting bigger, that means that they are getting lower, because a bigger pipe makes a lower sound than a shorter pipe. But all of a sudden they get shorter again, and they look a little bit different. Now that's because, if you'll notice, the top of these are open pipes, but then we go to closed pipes, because as you'll learn in grade 11 physics, a closed pipe produces a sound that is double the wavelength of an open pipe, which means it'll be half the frequency, which means that it will sound 1 octave lower than a corresponding open pipe. So with these, rather than adjusting the pitch with a foil on top, there's actually kind of like a little wooden plunger situation that you can move up and down to affect the pitch. And same thing over here. These are the super long pipes, but by stopping them, we've made them sound even deeper and even lower. Now over here we have the chimes. So the chimes operate just the same as a set of orchestral chimes, where there's a hammer that hits at the top. This works mechanically from the organ. Someone down at the organ will press the corresponding key, and it will move that hammer. We began by looking at flutes and saxophones and talking about flue pipes and reed pipes, and now we're going to see how those come together. On the right, you see a lot of cylindrical pipes. These are the flue, F-L-U-E, pipes, which make most of the sounds, specifically the flute, string, and diapason, or regular organ sounds. These pipes have no moving parts, and what is vibrating is just a standing column of air. And there's a little slit called a window, just like a recorder, functions in the same way. They're cylindrical, meaning that the width of the pipe is the same for the entire length of the tube, and that gives them a more mellow sound. Now on the very far left, you see ice cream cone-shaped conical pipes. These are the reed pipes, and just like the wooden reed on the saxophone, they have a piece of metal that vibrates to produce the sound. Conical shapes make brighter sounds. The organ has existed in some form or another for over 2,000 years. And if you went to Renaissance-era Europe, you would find that not only was the organ at the spiritual center of each town, but it was also the most sophisticated piece of technology in that town, along with the town clock. Now, in modern life, for keyboard instruments, the organ has largely been supplanted by the piano, which Beethoven called the queen of the instruments. But it still maintains its place in religious life through its sheer power and tonal versatility, which led Mozart to call it the king of the instruments.